Hello and welcome everyone. Thank you for joining us for the Tech Talk on Kubernetes monitoring on Splunk Observability Cloud. This is the fourth in the series of our Tech Talks where we share insights into how our growth engineering team at Splunk is adopting Splunk Observability. A reminder that all lines are muted as this session is being recorded and will be shared with all attendees. We love questions, so please submit them to the questions with the Q&A option at the bottom of the WebEx. We will address them towards the end of the session and afterward. The video replay will be available on Splunk Community Tech Talks. Again, thank you all for attending. To start us off, I request our esteemed speakers for today to introduce themselves, starting with Sudhakar.
Thank you, Ramakrishna. Hi, everyone. Thank you very much for joining today's Tech Talk. I'm Sudhakar Smilly, Senior Director, Head of Growth Engineering at Splunk. I've been leading this team for past 6 years. Divya, to you.
Thanks, Sudhakar. Hey everyone, this is Divya, working as a senior full stack engineer in growth engineering team. Thanks for joining.
Thank you, Sudhakar and Divya. And I'm Ramkrishna Kamath, your moderator for today. I'm a senior technical analyst with the growth engineering team at Splunk. We are excited to be sharing some great content with you today. This is the fourth episode in our Tech Talk series. Previously, we talked about how our team adopted RUM, APM, infrastructure monitoring, and synthetics monitoring. Today, we will talk about how our team uses Splunk Observability Cloud for some of our Kubernetes monitoring use cases. We will start by providing a quick overview of the growth engineering team at Splunk and our own digital resilience journey, followed by how we have adopted Splunk Observability Cloud for our Kubernetes monitoring use cases, and we'll end it with a demo. Towards the end, we'll have a Q&A session. Please use the Q&A option at the bottom of your screen to send in your questions. I'm sure many of you on this call are also trying to address some of the complex, interesting, and business critical use cases for Kubernetes monitoring. So without further ado, I invite Sudhakar to kick us off.
Thank you very much, Ramki, for setting the stage. Kubernetes promises speed, scale, and flexibility, but it also introduces constant motion. What used to be a few servers is now thousands of short-lived containers, each generating its own signals owned by different teams and running across hybrid clouds. The result is incredibly powerful but complex too. Kubernetes is powerful because of its dynamic, but the same dynamism also creates real complexity for anyone trying to monitor it. We're dealing with multiple layers, from applications and servers down to pods, nodes, and clusters, each constantly scaling, shifting, and rescheduling. On top of that, different teams own different pieces: DevSecOps, SRE, and SecOps, each using their own tools for metrics, logs, and traces. That fragmentation leads to silos and slower response when actual issue happens. At its core, Kubernetes is a distributed control system, a control plane with API servers, schedulers, and etcd, managing a fleet of worker nodes, each running pods, workloads, and ingress controllers like AWS ALB. Every component emits data, but none of it means much until it's connected. The real challenge is visibility, understanding how all these moving parts behave together in real time. I really like this meme when thinking about Kubernetes. When you first start working with Kubernetes, it feels like amazing. You can deploy applications in seconds, scale with a command, and watch everything auto heal. But then comes the real life, the 2 a.m. struggle, the intermittent latency spikes, the pods that keep restarting for no obvious reason. Suddenly you're juggling through YAML files, load balancers, node groups, 5 different monitoring dashboards, just to answer that one question: what actually happened? The reality is Kubernetes is not static. It's constantly moving underneath you. Every new deployment, every scaling event, every change in configuration can ripple across the stack. That's where most teams start to feel the frustration. You're not just managing containers, you're managing complexity that never stops changing. It's easy to think of Kubernetes challenges as purely technical, but the ripple effect extends far beyond the engineering team. When data is scattered across these tools and teams, every outage or performance issues turns into a relay race. DevOps is looking at metrics, SREs are digging through the logs, SecOps is scanning alerts, but nobody's seeing the full picture of what's actually happening. The disconnect is not just frustrating, it's costly. It's lead to slower mean time to resolution, duplicate effort, and sometimes decisions made without understanding the true customer impact. For the business, this means a lot more than downtime. It means lost productivity, delayed releases, and damaged trust when customer-facing services slow down or fail. In other words, this is not just about keeping clusters healthy, it's about keeping the business resilient, responsive, and ready to adapt in real time. So before we dive in, let's start with a poll.
Thank you for setting the stage, Sudhakar. So to all the attendees, we have a poll to gauge your familiarity with Kubernetes monitoring. The question is, do you feel Kubernetes monitoring differs significantly from traditional infrastructure monitoring? The first option is yes, it's more complex. The second option is no, it's essentially the same. And the third option is not sure. You should see a Slido option to answer the poll. Please take a moment to answer. Thank you for that great information about your understanding of the Kubernetes solutions. This provides a perfect segue for us to walk you through the reason for using Splunk Observability. A lot of you are saying it is indeed more complex. So let us get into how Kubernetes monitoring observability is helping us. Back to you, Sudhakar.
Thank you again, Ramakrishna. Before diving into the product, I'm proud to introduce the people who have made it their mission to drive the amazing digital experiences every day for our customers. As this is the fourth tech talk in our series, some of you may have heard this before, so I'll keep it brief. For new joiners, as a quick reminder for returning attendees, our team is the engineering group supporting the marketing organization. We manage marketing-owned external websites, including Splunk.com, and we integrate new MarTech tech stack that enhances marketing at Splunk. We also work closely with our vendors and partners to understand their products and applications, ensuring we extract the maximum business value. To make that possible, we rely on Splunk Infrastructure Monitoring to give us end-to-end visibility across our entire application stack, including Kubernetes environments. So we can see how every service, node, and cluster connects to the customer experiences. That combined with Splunk synthetics allow us to proactively eliminate issues, optimize web, mobile, and API performance, and ensure our digital experience are fast, reliable, and resilient. This is what our growth engineering team manages every day. A living, breathing ecosystem of microservices, data pipelines, various tools across multiple clouds. It's powerful, but also fragile. Every deployment, every dependency, every signal adds complexity. And when each layer has its own tools and owners, blind spots grow fast. For a team moving this fast, visibility is not optional. It's how you stay agile, deliver great customer experiences, and avoid getting caught off guard. So the challenge was not more data, it was how to connect it all. Splunk Observability brought everything together: metrics, logs, and traces in one real-time view. The Splunk platform collects and analyzes and makes sense of logs from applications, infrastructure, and security system across the ecosystem. Building on the foundation, we are combining app dynamic strengths in application performance monitoring for traditional three-tier environments with Splunk Observability Cloud's strength in cloud native and microservice architectures. App Dynamics also adds application security and vulnerability detection, as well as network visibility through integration with Thousand Eyes. Because these solutions deeply integrate with the Splunk platform, teams like Growth Engineering can see logs, metrics, and traces in one place. With the full context, they need to troubleshoot and optimize faster. Now the team can see across Kubernetes, cloud services, user journeys, detecting issues early, tracing them end to end, and resolving them before they hit customers. They've gone from chasing outages to predicting them, turning complexity into clarity and resilience. That's the power of observability done right. And it's why this team chose Splunk. We have talked about this in the previous tech talks as well. But Cisco's extended network and monitoring capabilities like App Dynamics, Splunk is the most comprehensive observability solution available today. And I'm excited for our future improvements in driving even better customer experiences with integrated capabilities across application infrastructure, digital experience monitoring, plus AI ops and incident response, all in one unified observability solution. With Splunk Observability Cloud, no need to license and adapt separate point solutions for each of these. You get all of them in one platform with a unified experience.
Thank you for that overview and insight into the complex technical landscape we are all faced with today, Sudhakar. That leads us into our next poll question. The question is, how mature is your organization's Kubernetes monitoring strategy? The first option is nothing in place, but we'd like to start. The second option is just getting started. The third option is basic monitoring is in place. And the fourth option is highly optimized and proactive. Please take a moment to answer the questions. Thank you for the responses. From the responses, we see that a lot of you have indicated that you have basic monitoring in place. And for quite a few, they already have a highly optimized and proactive monitoring strategy. So before we move on, just a reminder that we have a Q&A session towards the end. Please submit your questions using the Q&A option towards the bottom of your screens. I now request Sudhakar to provide us with an overview of our digital resilience journey.
Let's take a look. Thank you, Ramakrishna. Like our customers, our growth engineering organization is also on a journey to build digital resilience. Fast forward to today, and we have adopted all of Splunk Observability, giving us the ability to focus on how we deliver the most optimized experience for our customers. Here are the capabilities our team experienced with Splunk Infrastructure Monitoring. Today, my colleague Divya will be covering these use cases in a greater detail, followed by a demo. Handing it to you, Divya, take it over.
Thanks, Sudhakar. Hi, everyone. This is Divya. Let's start with foundational visibility and see how we have optimized cloud monitoring. Cloud and Kubernetes environments are inherently complex. To optimize monitoring, full visibility without slowing teams down is key. And that's where the Splunk OpenTelemetry collectors comes in. We deploy the collectors across Kubernetes clusters. It's quick, lightweight, and easy to set up. This single agent gathers metrics, logs, and traces from every workload, gives a unified view of the environment. With zero-code instrumentation, telemetry is automatically captured from all services. No developer effort required. Finally, Splunk Unify dashboards correlate infrastructure and application data, delivering faster insights, quicker root cause detection, and smart cloud optimization. As we progress from foundational visibility, we can get guided insights and context to detect threats and investigate issues. Infrastructure monitoring was critical for our team to reduce alert noise. When we first monitor our Kubernetes environment, alert noise was a major issue. Every small deployment fluctuation triggered notifications. Rolling updates caused harmless latency spikes that flooded our channels and distracted the team. We solved this by correlating performance data with releases, so normal rollout variations were suppressed, and only true issues, sustained latency, errors, throughput drops surfaced. Next, we tracked nodes, pods, stability trends. Instead of single failures and ad forecasting to predict scaling needs before problem occurred. This smarter layered approach turned noisy monitoring into actionable insight. So the team now focus only on alerts that truly matters. And as our observability practice matures, we can become more proactive so that we can aim to catch issues before they impact users. Our goal was simple: deliver a flawless user experience by spotting and fixing issues before customer notices. We built a proactive monitoring strategy in our Kubernetes environment, continuously tracking key metrics across pods and nodes. By correlating latency, memory, and response time anomalies, we detected issues early, found root causes fast, and reduced downtime. Then we added trend-based forecasting to anticipate demand spikes and trigger scaling before performance dropped. The result? We moved from reactive firefighting to predictive stability, giving users a smooth, reliable experience while our team stay ahead of the problems. The Splunk Observability AI Assistant is like our night shift guard. It catches problems before they wake us up with alerts at 2 a.m. It watches latency, errors, throughputs around deployments, stopped regressions faster than you can say oops. During upgrades, on request, it spots part tantrums and several meltdowns before users even notice the drama. It even calls our slacker nodes and stressed out services, helping us trim costs without breaking a sweat. Basically, it's an unsung hero that keeps Kubernetes running smoothly and us sane. The growth engineering team has also experienced how we can standardize practices across the broader Splunk organization using infrastructure monitoring and APM in Observability Cloud. With Splunk Observability IAM, all teams use the same tools and dashboards. No more dashboard turf wars. Automation catches and fixes issues faster, slashing downtime. SREs get self-service access to clusters and pods so they stop bugging others for scripts and can troubleshoot instantly. This unified approach makes monitoring simple, fast, and reliable, less chaos and more coffee. Let's watch this come to life in the live demo. Today, I will be talking about infrastructure monitoring in EKS Kubernetes using Splunk Observability. We will explore real-time visibility into clusters, nodes, and workloads, and leverage AI assistance for faster insights and troubleshooting. In this demo, I will cover how to use the built-in dashboards to get end-to-end visibility and how to build a detector that will alert you proactively, and how to diagnose issues, assess their impact, and triage them. Also, how AI Assistant helps you identify deeper bottlenecks, reduce the MTTD and MTTR. In short, this demo shows how to keep your Kubernetes environment healthy, reliable, and performing at its best. Without further ado, let's get into the demo. First, let's look at how easy and quick it is to get Splunk Observability up and running on Kubernetes cluster. All it takes is installing Splunk distribution of the OpenTelemetry collectors using a simple Helm chart. That's it, just few commands and you're ready to start collecting metrics, logs, and traces. Once you follow this guide and install the collectors and configured, telemetry data will flow from your cluster into Splunk Observability Cloud, enabling you to monitor and alert on your infrastructure end to end. Let's jump into Splunk Observability Cloud and see how Splunk Infrastructure Monitoring provides visibility into our Kubernetes environment. After you log in, go to Infrastructure and click on Overview. And on Overview page, click on Kubernetes clusters. What you see here is Kubernetes built-in dashboard inside Splunk Observability Cloud. This dashboard provides a unified and dynamic view of entire Kubernetes landscape in different prospects like clusters, containers, workloads, stateful sets, and many more. Cluster container daemon sets, which gives you a complete overview of the EKS environment, and also it gives CPU utilization and memory utilization overview. Let's dig into one specific cluster. Here we can view aggregated metrics such as CPU utilization, memory utilization, and node network utilization across all nodes within that cluster. This helps us quickly identify anomalies. For example, which node has the high load and easily can be identified. Splunk also integrates seamlessly log observer and application performance monitoring. This allows us to correlate metrics with logs and traces. So when an issue occurs, we don't just know that something is wrong. We can immediately understand why it's happening. Now let's talk about detectors. Detectors in Splunk Observability help you identify anomalies and get notified when your metrics deviate from normal patterns. For example, let's say here my CPU utilization is around 20%, and I want to be alerted whenever it exceeds 50%. To do this, just click on bell icon and click on new detector from chart. On detector linking, click on OK. And given a specific name which is relevant to your detector, create alert rule. This opens the new alert rule workflow. On alert signal, you can decide which node, which pod, or which namespace this alert need to be triggered. And go ahead. As of now, I'm going with the default selection. Proceed to alert condition. The alert condition can be based on static threshold, heartbeat check, or sudden change or historical anomaly. But for now, I'm going with the static threshold. Proceed with alert settings. I want an alert to be triggered when my CPU utilization reaches 50%. So I'm giving the value as 50 threshold. Proceed alert settings. Runbook. Point to the relevant cluster dashboard for quick triage. And the tip. Describe the issue briefly so that any team member can quickly understand what's happening and where to check. Proceed to alert receipts. Splunk Observability Cloud provides out-of-the-box integration with email, WebEx, and other collaboration tools, so alerts can be routed instantly to your preferred channel. For now, I'm giving email ID. Proceed to alert activation and activate the alert rule. Once the detector is enabled, Splunk will automatically monitor CPU utilization. Whenever the usage exceeds the defined threshold, an alert will be sent to the configured user or channels. By reviewing the alert details, you can quickly determine what is occurred, which node or pod was affected, and what triggered the spike. If the high CPU happening during peak business hours, you can proactively take corrective action. Now that we have explored how to see a built-in dashboard and how to create a detector to translate issues into actionable alerts, let's put all of this into action with a real-world use case. For that, go to Alerts and click on Active Alerts. and and select one of the critical alerts here. For now, I'm choosing desired and available pod detector where I see there is a critical alert on pod availability. Let's click on this alert. Okay, here I noticed a pod that's been restarting repeatedly, and that's what triggered this alert. And also I see my desired pod on my cluster is 8, but I see only 7 are available. Now, if I notice here the AI anomaly detection, which automatically provided me next steps, and it even gave me a direct link to the infrastructure dashboard, which I can explore further. Let's click on this Kubernetes deployments. Here we see all the deployments running in the cluster and that specific namespace. In deployments overview, I see the desired pods are 8, but only available are 7. In the deficit details, I clearly see there is one commons deployment, which is deficit. Let's click on this deployment and see what's happening here. Okay, on commons deployment, but desired pods are 1, but I see none of the pods are available, that is 0. Let's see, understand, is there any traffic spike or what's causing this pod disruption? I clearly see there is a CPU spike. The moment pod went down, the CPU got cleared. And again, when pod is trying to come, again, the CPU is hacking. Even the memory is the same scenario. Even there is a huge network spike here. Uh, Let's correlate this with the application impact. Because none of the pods are available, let's see what the impact is happening on the application side. For that, on your CPU chart, click on chart actions and click on troubleshoot from this time window to APM, that is application performance monitoring. Okay, what you see here is the service map, the complete service hierarchy, which is running on your entire Kubernetes system. I clearly see here the common service is showing the red status, that means it's down. On click of it, it gives me a basic overview of that particular service. Instead of that, I want to go in detail and understand what's happening on the service. For that, let's click on this www common service. This is a detailed view of the service overview, but I definitely see the service availability rate has dropped to 30%. But one thing catching is the service connectivity towards the backend Redis, which is 2.89 seconds. It's a huge latency for any application. Retrieve or connecting backend takes more than 1 second. For that, let me trash these issues with few of the trace IDs through APIs. Let me go through of one of the API call by clicking on one of the trace ID. Let me click on one trace ID and see what's happening on the application side. Okay, my common service is trying to make a one get call, that is jobs. During that call, there's some exception occurred. Looking at the trace properties, I see there is definitely a latency of 8.5 seconds, but major latency is coming from the external world. You see 64.3% is coming from the external latency. Let's scroll down and see if I can find any more details on this issue. Okay. Definitely, I see the exception stack trace. Here, I see Redis connection exception and also connection pool too busy exception. With these two exceptions, I can understand one thing is the application is failing to make a successful connection with Redis, and also the Redis is giving pool exception, like the connections got reached out to max. Let's go back to our Kubernetes infrastructure dashboard and see what's happening on our infrastructure. For that, I'm going back to the Kubernetes cluster dashboard, and on the filter, I'm selecting Kubernetes stateful set. There is only one cluster, that is one stateful set running on my cluster, that is Redis. Let's click on this. All Redis pods looks healthy overall, but during this time window, I see there is a CPU spike and also memory reached its max limit. Also, there is a network spike as well. At this point, it is clear that root cause is the resource limits on the Redis cluster. There are too low during peak load. This causes delay in Redis responses, and also the connection what reaching to the Redis got maxed out. When they cascaded, the commerce service was impacted and the pod failures and overall application got impacted. Uh, by this, whatever the analysis I have done, few assumptions I made and what action items I can think of is in future, first thing, I need to increase my CPU and memory limits of my Redis as well as the application. And also implement auto scaling to dynamically adjust resources based on load. That's a perfect action item and opportunity for me to improve my infrastructure. Also, I'm going to set another detector to alert me whenever memory reaches max limit so that I'll know like my Redis is on the max limit. I need to add more memory to my Redis. And that's how by correlating alerts, APM traces, infrastructure metrics, all within Splunk Observability Cloud, we are able to move from alert to root cause in just few clicks with clear actionable insights. That's the power of Splunk Observability on EKS, end-to-end visibility, faster troubleshooting, and smarter operations. So far, everything we discussed involves manual process and assumptions, analyzing dashboards, checking metrics, and troubleshooting issues step by step. But now we have a powerful tool, something called Splunk Observability Cloud AI Assistant. Think of it as your AI buddy inside Splunk Observability Cloud that helps you to figure out what's going on in your system faster. Let's see how it helps us analyze and improve our EKS environment. Suppose I want to understand how one of my production cluster is performing. I can simply ask AI assistant, please analyze my cluster, my production cluster, and suggest areas of improvements. Uh, this is what the AI assistant suggested me. The AI assistant looked at all the metrics from the cluster, CPU, memory, pod status, and workload performance, and provided intelligent recommendations which improves my cluster health, resource optimization, investigate cluster restarts, and monitor network usage. Similarly, I want to understand during my releases or node upgrades how my service availability is there any impact on my service availability. So I simply asked in a plain English, highlight any drops in service availability during the node group upgrade. It clearly told node readiness was not impacted and also suggested the pod management and monitoring container restart. The word container got restarted. It is asking me to look into it. Similarly, on the APM side, whatever we have analyzed related to this trace ID, I asked AI assistants based on the trace ID, could you please analyze and give me the anomaly, what is impacted, and how can I resolve the issue with integration with infrastructure management and APM. Okay. It analyzed by the given trace ID and gave me a clear instructions what needs to be done. See here, infrastructure monitoring sessions, what it gave is look at your Redis cluster health and connection pool configuration. Please look at your configuration and also resource allocation. That was our major challenge, what we manually looked at it, but AI suggested it just in one question. In just a few natural questions, the AI assistant helps us validate releases, monitor infrastructure health, and respond to issues faster, making observability truly conversational and intelligent. That concludes my demo. Thank you. Okay. In this demo, we explored the infrastructure monitoring tools for Kubernetes, including cluster dashboards and alerts. We walked through a simple way to set up monitoring alerting for critical workloads and resources. We showed how to leverage proactive monitoring to prevent costly downtime or performance issues. We streamlined troubleshooting across multi-node and multi-service deployment by utilizing end-to-end visibility from pods and containers and underlying infrastructure. Finally, we demonstrated how an AI assistant can help analyze metrics, detect anomalies, and suggest proactive actions for cluster health. Thanks, Ramki.
Thank you for that splendid demo, Divya. With that, it's time for our final poll. Which Splunk Observability Cloud Infrastructure Monitoring features would be most beneficial for your team and organization right now? There's a multiple choice question. So the options are full stack visibility that covers Kubernetes infrastructure and applications. The second option is AI driven analytics for anomaly detection. The third option is out of the box dashboards and alerts. The fourth option is open telemetry integration. And the final option is troubleshooting workflows for faster MTTR. Please take a moment to submit your responses. Okay, looks like close to 80% of you feel that the full stack visibility feature would be most beneficial for your teams. Thank you for submitting your responses. Again, thank you all for the participation. We are excited with you joining us. Now I'll hand it off to Sudhakar to share a summary of how Kubernetes monitoring has helped us.
Thank you, Ramakrishna. That was wonderful demo. Thank you, Divya. As you can see on this slide, the growth engineering team results speaks for themselves. These results are amazing so far. By using the Splunk Observability Cloud, we have gained end-to-end visibility across cloud and Kubernetes environments, improving teams' efficiency, quicker recovery, and smarter scaling decisions. What's even more powerful is how we achieved it. By building a culture of data-driven experimentation and continuous improvement, where every deployment, every anomaly, and every success adds to the operational intelligence. The good news is that it's not just for growth engineering. By adopting Splunk Observability Cloud, every layer of your digital proof footprint, from networking to the Kubernetes cluster, generates data that can make your organization stronger. Cisco and Splunk together turn the data into resilience. By combining Cisco's network intelligence, Thousand Eyes visibility, and Splunk's full stack observability and analytics, we give organizations the ability to see, understand, and act across their ecosystem, whether it's application in Kubernetes, cloud infrastructure, or user and device data. With this level of visibility, teams can now connect every service, pod, cluster to business performance, pinpoint root causes instantly, and get AI-driven recommendations to remediate and optimize faster. That's what digital resilience looks like, powered by Cisco and Splunk. And speaking of what digital resilience can look like, I think we have one of our observability leaders on the call, Hemant Seth, who is our principal product manager for infrastructure monitoring on Splunk Observability Cloud, who has some exciting announcement to share around new Kubernetes experience. With that, handing it to you, Hemant. Take it over.
Thanks, Sudhakar. Hi, everyone. My name is Hemant. I'm PM. I'm the product manager for the Kubernetes experience in Splunk Observability. And I just wanted to take the opportunity to talk about a new release that's coming out November next month, where we are introducing a brand new experience. So a little bit about the experience. So this is going to be an opt-in experience, meaning that you will see a button in your UI, which will allow you to try the new experience. And the idea of this new experience is that we want to focus more on the table views. We realize that the table views is like people want to use Kubernetes more for real-time operations as well. So table views becomes very useful. So there's a lot of enhancements that we have added into the table view, and there's a lot of new things with, for example, things like in-context navigation. So when I look at the list view and I want to look at the details of an object, I can just pull up those objects as a flyover rather than changing my page and losing that context. You'll be able to do all those sort of things. There's all sorts of customizations available on the table view. So it's a pretty enhanced view of the table view. And we want to, so the old charts that you just saw in the demo, they are not going anywhere. They're still there. It's just they will be under a different tab called dashboards. But the table view allows you to sort of get the data in more real time and be able to troubleshoot more quickly and get the data very quickly. Also, we have the left side. You'll see a more enhanced view of the faceted filters, where we have put a more detailed structure to these filters, so it's very easy to find a specific structure. So for example, you're looking for a filter that may be related to an APM service, or a filter that may be related to your environment, like a region or AWS region. Now you have a proper structure that you can very easily find those filters, and those are the sort of things that we have sort of introduced in this new version. There is a lot more that's coming with this new version. So starting next month, you'll see this new experience, which is more of the UI enhancement. But going forward, we are also planning to add things like YAML configuration. So again, one key thing I wanted to mention here is Kubernetes is not just about metrics and logs and events. YAML and the desired state of the Kubernetes is also very important, which was missing in the product today. So that's something that that's a big thing that we are adding, which you will see in the next versions. Be able to collect your YAML configuration files and see those things as well, so which will allow you to do a more deep level troubleshooting. All right, that's pretty much what I wanted to cover. So like I said, this is going to be available starting November, sometime mid-November. This will be made available, and it's going to be an opt-in experience.
Thank you very much, Hemant. Can't wait to see and start using them. Thank you very much.
Yep.
The Kubernetes infrastructure we manage is complex, spanning on-prem clusters, hybrid environments, and multi-cloud deployments. Monitoring along with an AI assistant plays a crucial role in understanding system performance, detecting anomalies, and resolving issues before they impact real users. Take a moment to identify 3 to 4 critical cluster performance availability challenges and map them to relevant monitoring, alerting, or AI-assisted remediation use cases. Our experience shows that you should give it a try. Until you do, you won't realize how much smooth operations can be. Consider signing up for Splunk Observability Cloud trial.
Thank you, Sudhakar. So we've taken some time to compile a list of resources we thought would be useful related to this tech talk. So these and other additional information will be available to you post the session. So hope you find them useful. With that, it's time for our Q&A. We've had a lot of great questions come in. Please send in any additional questions you have. We will answer as many as we can in the time that we have left. And for the ones that we cannot get to, we'll be sharing our responses through email and through community. I see a question here. So beyond the technical capabilities, what's one piece of advice you'd give to teams looking to foster a more observability-driven culture within their organization when dealing with Kubernetes and cloud infrastructure? Sudhakar, do you want to take that?
Thank you, Ramki. Happy to. Start by making observability a shared responsibility, not just a tool set owned by one team. The biggest pitfall I see: partial buy-in. When even one team is not collaborating or contributing telemetry, you create the data blind spots that break all that missing in that big picture. The best organization treat data as a shared language that connects dev, sec, ops around the common view of service health and customer experience. Encourage teams to collaborate early, automate whatever possible, and treat every incident or deployment as a learning opportunity. That's when observability shifts from something you monitor to something you practice. Makes a huge difference. Thank you.
Thank you, Sudhakar. There's one other question. Can the Splunk hotel collector run without any init container like rel or UBI image to patch the application log directories of files for the file permissions without a root privilege? Divya, do you want to take that?
Yes, thanks, Ramki. Splunk Open Telemetry Collector can run without init container and without root privileges to handle log file permissions. This is achieved by configuring Kubernetes security context for shared volumes or by ensuring the application write logs with appropriate permissions that allow the non-root collector use to read them. The collector is designed to run as a non-root user for most use cases. Yeah, hope it answered.
Thank you. There is one on agentic AI. What is the agentic AI use cases that can be achieved by Observability Cloud? And what are agentic AI capabilities that are present in Observability Cloud? Sudhakar, do you want to take that?
Happy to. Yeah, I can start. Feel free, anyone, to chime in as needed. Splunk and Cisco are seeing the need for the observability cloud world evolve not just observability but agentic observability. And when we think about agentic observability, there are three components: using AI to work smarter and faster, observability agents and infrastructure, unify observability and show business impact. All these are scratching the surface of what our teams are doing to meet the agentic movement. As an instance, AI to work smarter, look at ITSI Event IQ, which is already GA'd. At .conf, we also allowed more agentic features that will be alpha by end of the year. AI troubleshooting in Observability Cloud, App Dynamics and ITSI AI directed episode summarize, which is in alpha today. And getting into observe AI agent and infrastructure, we have AI agent monitoring Observability Cloud. We have AI infrastructure monitoring already GA'd, AI agent monitoring and app dynamics already GA'd, and few others in the unified observability. As an instance, digital experience analytics and Observability Cloud to gain visibility into user behavior and usage and more. We'll share the detailed response when we send the email out.
Yeah, thank you for that, Sudhakar. So we have, what are the three things you just can't imagine doing without having observability right at your fingertips? Divya, do you want to take that?
Sure, Ramki. Uh, Great question first. I can't imagine troubleshooting incidents instantly, like finding fail pods or services without executing like multiple commands. Second, monitoring performance under sudden traffic spike would be nearly impossible without real-time metrics and traces. And analyzing root cause across system, correlating logs, metrics, and traces across my entire stack would take forever if I don't have Splunk Observability available. With Splunk Observability Cloud, all of this is right at my fingertips, gives full stack visibility in just seconds.
Thank you, Divya. The next question is, what's the key difference between Splunk Observability Cloud and Splunk App Dynamics? Sudhakar, do you want to take that?
Sure, definitely. To answer this question, let's quickly go over the Splunk portfolio, how it all comes together. The foundation of this portfolio is the Splunk platform, which includes Splunk Enterprise and Splunk Cloud, that provides underlying layer for logs, analytics, and data management and identity. At the application and infrastructure and user experience layer, we have App Dynamics, which is optimized for three-tier and entire application and self-managed environments. Observability Cloud, on the other hand, is optimized for cloud-native environments and caters to customers that have strict requirement for open telemetry. ITSI ties these components together with an overall intelligence layer triggered at IT ops teams. It brings business services monitoring and event analytics coupled with powerful AI and ML capabilities. Thank you.
Thank you, Sudhakar. See one other question. Is it mandatory to send metrics and traces collected by OpenTelemetry collector to the Splunk Observability Cloud while logs go to Splunk Cloud? Or is there flexibility in routing all telemetry types to a single destination? Are there any technical limitations and how Log Observer can be utilized for troubleshooting? Divya, do you want to take this?
Uh, Short answer, uh, you have flexibility. You don't have to force metrics or traces to Splunk Observability Cloud and logs of Splunk Cloud. The Open Telemetry collector can be configured to route any combination of metrics, traces, and logs to different destinations. However, there are practice that features related limits you should be aware of, like the token endpoints and retention search features, ingress, and what each Splunk product enables. Uh, but I can give you more details over the email on this question. But yes, it is possible. Hope that answers.
Thank you, Divya. There's one more for you. Can you share a specific, perhaps challenging use case where Splunk IAM's capabilities significantly reduced mean time to resolution or helped the team to correlate their SLOs to business impact?
Yes, there have been multiple incidents. But if I have to pick one, it would be during .conf 25 event. Our application was stable, and we anticipated a modest 20% increase in traffic. However, the actual surge was staggered 100%, overwhelming our infrastructure. This unexpected spike led to significant CPU and memory utilization, threatening our service level objectives. Fortunately, our Splunk infrastructure monitoring detectors promptly alerted us to the anomaly. This early warning enabled us to swiftly add more nodes and to the cluster, restoring balance. By leveraging Splunk Observability Cloud infrastructure monitoring real-time alerts, we maintained our SLOs and ensured uninterrupted service during this critical event. Really, the alerts, whatever we have enabled, helped us here.
Thank you, Divya. I think that is all the time we have for the Q&A today. Thank you everyone for submitting your questions. So we just wanted to let you know that you can continue the conversation on community.splunk.com. Please sign up if you haven't, or if you already are a member, sign into our community. So we have a community office hours, which is a bi-weekly series where technical Splunk experts answer questions and provide how-to guidance. And we also have an upcoming tech talk on Splunk Observability for AI. In this tech talk, we'll show you how Splunk's agentic AI observability delivers end-to-end visibility of the entire AI stack, from agents and large language models to the underlying infrastructure. So please consider registering for the tech talk. So that is all that we had for you today. Thank you everyone for joining. We had a lovely time bringing all of this content to you, and we hope that our digital resilience journey resonated with you. Thank you for spending the time with us today. Request you all to please take our Tech Talk survey and let us know how we did. Until next time, thank you again and have a wonderful day.